Welcome to the physics lab. Today we are doing lab 8, the oscilloscope, which for some reason is called inductance and capacitance in the lab book. I don't know why. Alright, so the first thing we're going to do, we're going to get right to the lab part of things. And it says here, let's go over what we got here. This is called a decade resistance box, or a resistance decade box. And you can tell this because it says at the top, resistance decade box. Now, there's these comparator outputs, and then there's the decade outputs. We'll be using the decade outputs. This, you might remember this from this is our signal generator. This is our really old and ancient, obsolete oscilloscope from HP. This is probably old enough to have grandchildren. It's ancient. And you know what this is. Okay, so signal generator, oscilloscope, decade box. Now the thing with the decade box is you can set it. Now what I want you to do to start with is just set it all to 0. Okay, in fact we're going to disconnect this and this. And we'll just set it to 0. Then if we take our handy dandy multimeter, we're not going to be measuring any current, and we turn it on and we set it to resistance, and we'll set it to 20K, and then we put our leads across here like this. Right now it reads 0. Wow. And then if we change this, you want it all to read 0 first to start with. Then you change this to 5,000 and change it to 4. And if you look at it now, it reads 4.99 kilo ohm. Is that right, Keely? Kilo ohm?
Yeah.
Keely is the camera person. All right. So now we know that is set correctly. So then it says to change this to volts AC. When we do that, we don't have to move any of the cables. 2 volts AC. And then we are going to set up the rest of the circuit. I already have it set up here. We have the inductor here in the middle, this big guy here. He's measured in henries, not Hanks, henries. And we put it on here and here. So we've got the signal generator cable going, red one going to here, then the black cable going to the inductor, then the other black cable coming out the other side of the inductor and going back to the signal generator. Now what we're going to do is we're going to set up the voltage probes to measure the AC voltage. Right now it reads pretty close to 0. Why? Because the stupid thing is off. It should be 0. So we turn it on. And it's going to turn on at 1000 for frequency. And the amplitude is going to be something. Right now we can see it's measuring 0.694. So we turn it up until we get to what it says, which I forget what it said to go to because I got to go look it up in the book. It says to go to 1. I should remember that. So I adjust this, and you can get it right on 1 if you're really good, but I probably am not, so I'll just do the best that I can. Oh, oh. My hand moved. Just as it was. Okay, that's good enough. And you write that number down, I'll have a spreadsheet for you and everything. Okay. Now it says, so we've got 1 volt across the 5 kilo ohm resistor, and now we're going to measure the voltage across the inductor. And, oh, it came out to be 0.125.
How do you find the NS?
So we'll write that down too, okay?
How do you find the NS?
So now it says, oh, okay, wait a minute. It also says to set this to 800, I'm sorry, I forgot to set this to 800 hertz first. That can change the voltage and the frequency, so I should have done this first. I set this to 800. Then I set this. Well, and look, oh, okay, it didn't change. Very interesting. It didn't change with frequency across there, but it did change with frequency across here. Now it's only 0.101. We shouldn't be confused with 101, which is a highway. Okay, so then it says to repeat this, increase the voltage, the frequency in the signal generator to 1400 hertz. So up to 1400. And now it's 0.173, but if we measure the voltage across here, okay, it did change some. Then we get it, now it's 0.992. All right, and then you do it for 2200 and 3200. We're not going to do that right now. That's what your job's. Okay, then we're going to do the same kind of experiment, but instead of using an inductor, we're going to use one of these guys. It's a capacitor. Not going to do that for you right now. It's the same kind of experiment. Okay, so next thing we have to do is do both of them at the same time. So we're going to turn this off for just a second because we don't want to be using a live. As you notice, I put two of these little crossy thingies like this. I'm going to move this over to here, and now I'm going to have. Let's put it. Let me see. I do it the way the book says. Capacitor should be. Capacitor should be here.
How can you see the folder? This folder is on your P21.
And the capacitor, if I can connect it. See why I did this before the camera started. I'm having a real fun time here. Of course, my lab assistant could be helping me, but I don't have one today. And I could be laughing at my lab assistant. There we go. I think that's right. Looks awful, but it looks okay. It's okay. And then it goes from there. And now we're going to set the decade box, instead of up at 5 kilo ohms, we're going to set it down to 100 ohms. Now, it's usually a good idea to check. And the way you check is you have to actually disconnect it first, at least one side of it, then measure the resistance. I'm not going to do it right now because I don't want to take up the time. But you should. Don't forget, you should, okay? Don't let me catch you not doing that. All right. Now we're going to get to the part of the lab. You remember this lab was called the oscilloscope, and we haven't done anything with the oscilloscope except use it right so far to hold up the signal generator. But now, we're going to start doing it. In fact, the first thing you should do is turn the oscilloscope on just so it has time to warm up. All right, if you look, you have a row of 8 buttons on the bottom and 7 buttons on the side here. Those are important. First thing we do is we turn it on. Or we already did that. We did that at the beginning of that. Now, if you don't see anything, like right now I see, in fact, I'm going to turn this to, okay, we'll leave it like that. You should see a line like that. If you don't, you have a problem. Now, what is the problem? Well, it could be the intensity. It could be lots of things. First thing to do here, make sure this int button here is set right. It probably is. It was on mine. Okay. The horizontal line's there. Great. If it doesn't, then it's either probably with intensity or focus. If the intensity is turned down way too low, for example, it's gone. So this is the intensity. You got to get it warm enough so that you can see it, and you also don't want it to be too blurry. That's the focus line. So you want it to be nice and focused and nice and intense. If you can't get a line, come and see me, and I'll tell Greg there's a problem. Okay. So now we want to add the oscilloscope to the circuit. We won't need this for now, so let's take it away. All right. So what we have is we have 2 probes, A and B. I have a suspicion that one of these isn't working right now, and I'll tell you why in a minute. So this is the A probe. Okay. You take the A probe, and you connect it across the signal generator. So we put the black to black, and it falls out. Jeez. I'm not having much luck right now. And the red to red. Hopefully it'll stay longer this time. Now if we turn this on, we see a nice sine wave. Now you might have to adjust it because of the volts per division. See, you might end up with something like this, or something like that. But you can see it right there. That's pretty cool. Or it might be off the chart. That's another thing. If you don't see a line, it might be the position's not set right. It could be off the chart. Okay, that's pretty cool. And if you change the frequency, you can see it changes this too. So that's really cool. That's what all oscilloscopes are really useful for, by the way. No, I'm just kidding. Okay. So now what it says to do is, that's for channel A. Now channel B, we're going to set that one up across the decade box. It's 100 ohms. And the red on this case should be next to, headed to the capacitor. And the black, it says gray, but it's black, over here. Now for some reason, that just killed my signal. I don't know what's going on there. Anyway, the next thing you're supposed to do is hit this BA blue button here. This button should be on A, and that should be BA. I don't know what's going on. Why is that? Okay. Well, let's just disconnect this because I get something that's interesting to look at least. Okay. What you do then is you set the signal generator to 300 hertz. And what you see is, you see an ellipse. You can change the amplitude too. So you see this ellipse. What you want to do is to find the resonant frequency, you have to find out where it collapses to a line. Now this should look more elliptical. I don't know what's going on right now. It should look more elliptical, and when you change the frequency, it should be changed the shape, and it's not, and I don't know why, and I don't really care. We'll just have to figure that out next week. Let's pretend that is on it. So that is our. So we write down 363.5 because I think that's what it did. Yeah. And then what you have to do is you have to go up a little bit and down a little bit, but sort of like we did, if you remember, with the standing wave lab, where you went above and below the frequencies of interest to find the one where it's exactly gone. Like that time I got 343. But just you can just do it by yourself. Okay? Now it says to repeat this. Now what you do is you remove that, you go back to the digital multimeter and you read the voltages, just like you did before, across the signal generator. Anyway, it says how to do that. You adjust it to 1 volt. AC voltages, put it down. Adjust the output voltage from the signal generator to 1 volt. Okay, so this is, we take this off. And we set it, the amplitude, to 1 volt. And I just did it. Close enough. All right. Now you decrease the frequency by 10 hertz. So we're going to set it to 333. There we go. And readjust the amplitude until you get back to 1 volt. So I can bring it, there we go. Not much of an adjustment, but there it is. Okay, and you read and record the voltage across, now you go and read and record the voltage across here. And right now it's 0.452. Now you change the frequency again by 10 hertz, and you set this again to 1 volt, and then you read the voltage across that. You keep doing that every time. And you do it across the values will be in the spreadsheet. Okay? And you do it for frequencies above the resonant frequency and below the resonant frequency. It says to print a copy of the spreadsheet data for each lab partner, but we don't even print this, so you just, it says use something called Cricut Graph, we'll just use Excel. And you have to use some spreadsheet calculations. I'll try to make that clear in the, either in the another video or in the Excel spreadsheet. A lot of it is talking about the resonance graph, and what you'll see is the resonance graph. I think that'll be pretty interesting because this is the kind of stuff I've actually done for a living too, before I came here. And you'll probably see something where it goes, where there's a peak like that, or maybe it'll go like that. It depends on which way we're going. On your plot for the voltages. Anyway, and that's about it for this lab. It should be pretty straightforward. Now, has anybody got any questions? Oh, I forgot, there's a video. You can't ask any questions. Not that I really care. The secret code for this week let's see, what should we have for a secret code? Well, baseball season is starting, and I'm a big Dodger fan, so we'll make the secret code Dodgers. How's that sound? I'll see you in the physics lab.